Very good morning, everyone, and we'd like to welcome you all to our Kelsius webinar this morning. And it's going to be in the importance of product simulation and temperature monitoring for product safety. My name is Patrick Gallagher, and I'm the Customer Success Manager with Kelsius. And I'm joined for today's webinar with Kieran Gallagher, who is our Sales and Marketing Manager. So if you just want to say a quick hello, Kieran.
Hi everyone, thanks for joining.
And just before we begin the webinar for today, we do have a couple of housekeeping rules that we'd just like to run through. So first and foremost, your camera and mic are automatically off. If you have problems hearing presenters or viewing the presentation, check your device audio settings and network connection. You can submit questions during the webinar using the Q&A function, not the chat function. These will be monitored live and we'll answer questions at the end of the webinar. And if you have any queries or comments after the webinar, please feel free to email us at sales@kelsius.com. And also for anyone who can't be here today, there will be a recording of the presentation, which will be shared with all attendees after the webinar who have registered also. And I'm just going to pass you over to Kieran, who is going to begin our webinar for today.
Thanks, Patrick. Hi again, everyone. Just to kind of kick things off, as basic as it sounds, the first point to note is that air temperature is not the same as product temperature. It acts and behaves differently. And when you're monitoring a unit, the information, the data is going to look different. Air temperature is much more receptive to change than product temperature, and it can be influenced greater by things like door opening, unit-based activity like compressor settings, compressor cycles, and defrost cycles as well. So Patrick, just next slide. Thanks. Yeah, so one of the big, I suppose, issues with a lot of temperature monitoring based systems where they're set up around air temperature is that it creates a lot of what's in the industry called data noise. It's a lot of unnecessary alerts because air temperature rising is not on its own a threat to your product. Creating a lot of false positive alerts that can lead to what's classified as alert fatigue. It's a little bit almost like the boy who cried wolf, where you're getting a lot of alerts, but then people's are less receptive when they receive those alerts, so they're less switched on. They think it's just another alert, it'll be grand, and then when there is a genuine issue, that their defenses are down. So that's why it's very important to aim to have your alert set up around what your actual product is experiencing. Next slide there, Patrick. So when we look at the performance and the actual data of a given unit, and we compare the data of both the product and the air. So back when we started looking into this and doing some of the research into it, we conducted studies. So we had sensors put in place that applied our bespoke algorithm. We put them side by side alongside a sensor that had an external probe, and it was going into a glycol vial, and we also had a sensor going into an actual product as well. The data that we extracted from that, we were able to see that the air temperature was way more volatile in terms of change. The product temperature was behaving much more static, and you'll see if you look at the example of the graph there on the right hand side, the product temperature is in blue and the air temperature is in purple, and you'll see air temperature is up and down on the graph, and you'll see there's been quite a number of excursions above the critical threshold, but that on its own is not necessarily an issue for you. So when we apply the alert to the product temperature, which you'll see is a blue line, going along, not changing too much despite all the activity with the purple line, and that the things that can happen there are things like door opening, putting stock in, taking stock out. But you'll see the yellow dot indicates the actual issue, and just before the yellow dot had appeared, you'll see just down below the purple and the blue lines actually converge. So that's why we at Kelsius try to set up all alerts around the product of the temperature, and that's what we would recommend to any of our clients as well. Next slide there, Patrick. So how it works, we have an algorithm built in, again, that we've built based on the science and based on the actual research and data that we've got. So what we do is we monitor the air temperature, and that acts as the fuel, shall we say. It goes into the product simulation engine, and again, that's all based in science, which I'll discuss in a second as well. And then the output from that is your simulated product temperature. And if you consider the example of the engine, that's like your smooth running performance of your car as well. But the outcome for you, the benefit for you, is that you're getting real product temperature without needing a sensor with an external probe, or indeed with a glycol vial. Next slide, Patrick. So what's the basis for this? So again, it's all just taking proven scientific principles, and the one that's fundamental here is Newton's law of cooling. So I'm not going to pretend to be the expert on the formula in front of you, but maybe I'll leave that to Patrick. But it is important to know that this is all based from scientific data, and that we've done the research to prove this as well. So next slide, Patrick. So what's important from Newton's law of cooling? So air temperature and product temperature act and behave differently, but it is important to note that the temperature of an object, whether it be a product or whatever it is directly proportional to the air temperature surrounding. So that's how we've been able to map and graph and build this into our system. So the sensor takes the air reading, that's calculated on our system. Then the buffer algorithm is applied, and that is how we deliver the simulated temperature product. Next slide there, Patrick. So what that means for you and your business, or you and your organization, it means that you can move away from being reactive to being proactive, because you know that alerts are going to be generated when there is a genuine issue. And with that, staff can take preemptive action to ensure that the stock or product never gets lost, because you can move it from any unit that's experiencing difficulty. Next slide again there, Patrick. So the findings that we found from deploying this with our customers. So the first one is a massive reduction in false positive alerts, because we're setting them up against product as opposed to temperature. And we have been able to reduce that by as much as 85% in some scenarios. Because we've been able to do that, it's enhancing the product safety of the stock or samples that you have under your management. The knock-on effects of that are that you're making your customers safer, you're making your patients safer by doing so. The other thing is, as I mentioned before, is that it also removes the need to have a sensor with an external probe or with a glycol vial in a fridge or freezer, because that can get knocked over, it can get broken, or just moved. So it removes that possible point of failure. So Patrick, yeah, next slide, and I'll hand back to you.
Yeah, thanks very much, Kieran. So I'm just going to do a quick demonstration on how you view this data essentially in your Kelsius portal. So first and foremost, I'm sure you are all familiar, but you log on to your Kelsius portal. We actually have an account set up already just to show you this, but it'll be the same for your customer setup as well. So once you log on to your customer portal, on your left-hand side, you will see various different tabs. So where we want to go to view this data is the sensor graphs option. And then there will be an option there called temperature sensor graphs. And what this will allow you to do is it will allow you to select, you can select multiple sensors. But obviously we just have two sensors there, air and product configured. So for the demonstration, that's what we're going to display. And also I'm just going to select date range as well. So you can select any date range you want to view your sensor readings. I'm just going to pick the 14th of June as an example. And then obviously what you're going to have to do here is you're going to have to select the two sensors. So as you can see there, we have one labeled CS Fridge P and CS Fridge A. So I'm just going to select both of them and hit display. And what you'll see here is you'll see, similar to what Kieran mentioned earlier, you can see the graph of how the sensors are performing. But the important thing to mention here is that the purple line indicates your air reading and the blue represents your product reading. So typically what you can see here is this here is for one full day's worth of data. And what you can see is the purple spike is kind of up and down more so than the blue spike, which is your product. And that's typically what we would expect to see with your air readings. Obviously, the way I like to think of it is the air probably reacts in seconds as opposed to your product, your core temperature product of your product. That typically takes minutes to adjust to its environment. So that's a good example there where you can see the spikes and see the differences and how they react over a period of time. And again, that's something that everyone on the call can view as well. But it's all available on your portal as well. So on that note, I am just going to go back to our presentation and I'm going to check in here with Teresa to see what questions we have received from today's webinar.
Sure. Hi. Hi, everyone. Thanks, Patrick. And hi, everyone. It's Teresa here. I've just been monitoring our questions in the background and I hope everybody enjoyed that presentation. I think that was very striking, Kieran, when you talked about the false positives can be up to 85%. So hopefully, having the knowledge of this helps people to reduce alerts or, make sure that, they have a better understanding, I suppose, of how the temperature monitoring works to ensure that it genuinely is just monitoring the product temperature, which is obviously what you care about, whether that's food or medicines or healthcare products, rather than the air temperature around it. So thank you both for the presentation. I just, before I get on, there are a couple of questions in. I just saw a hand raised from Bernard there. Bernard, if you have a question, you can put it in the Q&A there. We'll still have a few minutes and I'm sure we'll get around to it. If you want to put it in the Q&A section, I'll have a read of it before the end of the presentation for Patrick or Kieran to answer. But as Patrick said earlier as well, you can email us if there's ever any questions. You can email us. You could use the support email support@kelsius.com if you have any questions, and the team would be very, very happy to get back to you anytime, whether that's after today's presentation or any time in the future. So just getting on to a couple of questions that did come in. Patrick, I might put this first question to you. Do I have to set this up if I already have your system?
So what I would advise there is obviously for healthcare customers and food customers, the settings can be slightly different. So what I would recommend is that if you do want to see how your system's set up, or if you need any guidance on setting it up, that you email our team at support@kelsius.com and they'll be more than happy to answer any questions you do have regarding product simulation.
Perfect, thank you for that. And another question, Kieran, I'll put this to you. The person asks, I'm getting a lot of alerts in the last few weeks. Is that because of the hot weather? So I'm guessing this person, they've seen a particular spike and it hasn't been ongoing. And they're asking, is that because of our exceptionally hot weather?
Yeah. I suppose the simple and short answer is that yes, the weather can impact on it. I think again it probably goes back to Newton's law of cooling, similar to the air and product. If you think of the air temperature in a unit, it is directly proportional to the temperature outside. So when the temperature outside increases, that's going to impact on the temperature in the unit. Obviously, the unit has compressors and tools to counteract against it, but typically they're set up to probably operate at the standard temperatures here in Ireland and the UK. So when that increases, they have to work harder. On top of that as well, you do find in a lot of scenarios, during hot weather, a lot of places are busier, so the excursions then are driven as well by a lot of more door openings and shops and places like that as well. So it does have a big impact on it.
Okay, good to know. I don't have more questions here, but I see another hand raised. So again, I tell you what, Patrick, I know you were going to wrap up for us at the end of the Q&A. What I might do is ask you to go through the contact details for us, and that might give people a chance, if there are one or two more questions, to put them in the Q&A section. But as I said, everybody, feel free, please, to email us at support@kelsius.com, or if you're a customer, contact your account manager. Very, very happy to answer any questions. So Patrick, if you could come back to me just after you go through the contact details, and I'll just double check if there's any more questions. Thanks, everybody.
Thanks,
No
Teresa.
problem. Thanks very much, Teresa. So just to wrap up today's webinar, on screen here, you will see our contact details if you wish to get in contact with us. So you can email us at support@kelsius.com. Our UK number is displayed, as well as our Irish number. And also you can check out our Kelsius website, www.kelsius.com, which has loads of helpful information on there as well. And finally, from myself and Kieran, we'd just like to thank you all for taking some time out to join us on today's webinar. And we hope you found it beneficial. Please feel free to email us any questions you have. We're more than happy to take them on board. We will be doing future webinars as well. We have one nearly planned every month. So we look forward to seeing you on future ones as well.
Thanks for that, Patrick. Patrick, I don't see any other questions, so I'll wrap up on behalf of all of us. Just to repeat what Patrick said. Thank you, everybody, for joining us today and taking time out of your day. And if there are more questions, as I said, please do contact us through one of those other channels. So thank you, everybody. Have a good day, and goodbye from all of us.
Thanks, everybody.
Everyone. Bye.